And we're live.
Hi, everyone. I'm Mahimna Kelkar. I'm a PhD student at Cornell University. And today I will be talking about MEV extraction and reorgs. So before I begin, I'll just have to point out one disclaimer I want to put out there. So this talk is somewhat more opinion-based and conjecture-based than the usual theoretical research style talks that I've given in the past. So just want to put it out there that this is not actual research and more opinion-based. So yeah, with that kind of out of the way, let's begin. So inherently, reorgs are not necessarily a new thing. Mostly, they've in the past been considered for things like double spends, where you're trying to spend the same coin twice, or things like selfish mining. The new class of reorgs that we've seen in the last few months has been mainly related to MEV. So something like miner MEV reorgs or reorgs as a service. So miner MEV reorgs are when a miner attempts to mine a block, like a previous block itself, in order to capture the MEV that's contained in it. And then reorgs as a service is similar, but instead of the miner capturing the MEV itself, it takes a bribe or a payment from a searcher and tries to reorg the chain according to how the searcher wants it. So for example, in these cases, if there's a large arbitrage opportunity in a previously mined block that was mined either by someone else or completely missed at all, then you could imagine the miner reorging the chain and trying to mine it himself. So let's start with two basic sort of assumptions. The first assumption is that miners are profit maximizing. So all other things being completely equal, miners want to maximize the amount of profit they can make from the system. And the second key assumption here is that there's a limit to this kind of profit maximization. So specifically, miners don't want to do anything to jeopardize their power within the system or the security of the system itself. In short, they don't want the system to fail because they're inherently vested into the system. So let's focus on the first assumption for now and see where it takes us. So we'll start with a simple example, and this is something that's been talked about quite a bit in the talk, but I'll briefly elaborate on it again. So suppose you have a chain where there's a large amount of MEV present in a previously mined block, so something of the order of millions or tens of millions of dollars. So this is MEV that was not extracted by anyone, or it's extracted by some other miner. And now if a miner sort of sees this opportunity based purely on the profit maximizing attribute, the miner will now attempt to mine this block itself to extract all the value inside. And this is what we'll call MEV reorgs. So a few points to note on MEV reorgs is that blocks will actually need to contain a significant amount of MEV for reorgs to be profitable. So remember that you need to spend a considerable amount of money to mount this attack. So unless the expected gain is really worth it, these reorgs probably won't happen. There's been some back of the envelope calculations recently that say something about the magnitude of $1 million or a few $1 million that's required to be in this MEV block. But more careful analysis of this is certainly needed. And in any case, even if these blocks are uncommon, they're probably not exceedingly rare. And especially as MEV extraction games progress, you could have more and more value being extracted from the block as the whole game becomes more streamlined. And there could very easily be blocks with these $10 or $20 million MEV, which would make reorgs for this very profitable. Another point to note is that this MEV auction game for reorgs with large MEV blocks, searchers will almost certainly be irrelevant, since any profit maximizing miner will simply want to extract the entire amount itself, and rather than take the bundle that's proposed by the searchers. So until now, we only considered what happens when a single profit maximizing miner attempts to do this reorg. Now, there'll likely be more miners that are trying to attempt to reorg the system at the same time to capture this large block of MEV themselves. So here I highlight two miners, one colored orange and one colored blue, that are each trying to reorg the system in order to extract this large MEV block. So this kind of leads to a prisoner's dilemma-like situation, where a miner wins if it attempts to reorg, but others do not attempt to reorg. So if you have the two miners, the orange one and the blue one here, if the orange one is honest and the blue one is malicious, then the blue one wins, and vice versa. If both of them are honest, then nobody wins, and the system is stable. And if both of them are malicious, nobody wins, but the system is unstable, and I'll get to that in a minute. But basically, if everyone attempts to reorg, then essentially nobody wins. And as many of previous talks have mentioned, this could create like an unstable system with a worse security. And what do I sort of mean by that? Essentially, when many miners try to reorg the chain to extract this MEV themselves, they might end up like stalling the system or competing with each other as they try to extract the MEV themselves. And this could be detrimental to security, since a separate attacker might not be able to extend the original chain and cause other damage while these miners continue to fight for the MEV. But at the same time, though, we could have like other honest miners in the system that can also continue to extend this original chain. So the game theory here is actually quite subtle, and probably needs to be analyzed way more carefully. So it's not immediately clear how much security is affected if there's some fraction of miners that continue to mine the original chain honestly, especially since like mining more blocks on this chain reduces the chance that any of the miners attempting to do the reorg succeeds. And as far as I'm aware, this is sort of an open problem that needs to be studied more. But in any case, all this discussion sort of brings us to the second key point that I mentioned previously. Miners don't actually want the system to fail. They usually have a substantial amount of capital or resources invested into the system, and they definitely don't want to jeopardize that. So what does this mean for MEV reorgs? Will they not happen, or will they happen? Well, maybe. I want us to take a step back and try to provide some terminology here. These type of reorgs that I mentioned in the past, I'll call them unstable reorgs. So unstable reorgs are when miners are fighting with each other, and they kind of are detrimental to the security of the system. So they're likely to be negative sum, and will likely not happen because of these like security concerns. But I will make one conjecture that if reorgs can somehow be made more stable, then they will definitely happen. And by stable here, I mean that they don't cause any like security problems. And to kind of provide a little more detail on this, if we look at the prisoner's dilemma table from before, we notice that only when one of the miner defects and the other is honest, the defecting player is the one that takes all of the reward. But if you look at the game theoretic problem here, the prisoner's dilemma problem, it assumes that there's no collusion between the players for splitting the rewards. And only then does this prisoner's dilemma become a dilemma. And that's sort of the key here. And another difference is that this prisoner's dilemma is usually like a one-shot game where decisions are taken at the same time. But for reorgs, you can take actions based on how other people are acting within the system. So there's a lot of interesting game theoretic analysis still to be done here. But still, if we can make it so that most miners, or both miners, or more generally more miners, win in the case where one is honest and the other is not, then there might not be a problem with respect to reorgs. And that is what I'll call stable reorgs. So basically, stable reorgs are a way to distribute value from a large MEV block across future multiple miners. So these will be focused mainly on large MEV blocks, because those are the ones where reorgs will actually be profitable in terms of like the amount of resources you have to put into the system to carry them out. So I'll put like a straw man proposal here is you can distribute the rewards evenly across a large number of blocks. So for these large MEV extraction opportunities, these like exactly the kind that are profitable for a miner to do, you can distribute them evenly across a large number of following blocks. A smarter way might be to proportion it in such a way that it's profitable always to mine the next block in the current chain, then try to reorg a block and mine on top of that. So essentially, we want to reach the following game state. So if there's a large MEV block that was unnoticed, it should be rational to reorg and extract MEV in some stable proportion. If this large MEV block was mined in an unstable proportion, so that's case 2, it should be rational to reorg and extract it in a stable proportion by sending the extracted MEV downstream. And the case 3 is that if there's the large MEV block that was mined in a stable proportion already, then it should be rational now to extend this chain rather than attempt to reorg again in terms of like the expected amount of profit that you would extract. And this basically will cause a rational stopping point. So essentially, if someone has already extracted the MEV from this large block in a stable proportion, then it should be rational to extend their chain than to reorg again, essentially circumventing the prisoner's dilemma. So basically, the open question is, does this kind of protocol exist? My intuition is yes, but the exact sort of optimal way to distribute MEV downstream will definitely need a lot more careful economic analysis. A couple other long-term potential solutions that I can just put out there is, one, you can try to hide the transaction data for as long as it's not, as long as, until it's no longer profitable to conduct this reorg. So basically, once the transaction data is revealed, it's no longer profitable for you to go back and try to reorg and capture that MEV. Another possible solution could be determining the transaction ordering from many blocks instead of a single block that is done currently. So this is kind of reminiscent of the joint proposals that you see from fair ordering protocols. And the upshot here is now you need to reorg several blocks to capture the MEV instead of just one block, because several blocks compute the final transaction ordering. I'll end with some sort of final thoughts. The first is that unstable reorgs I described that are detrimental to security will likely not happen. They might also be detectable, and other solutions could be used for them. There's also this notion of social consensus of, if things are detectable, then it would be hard for miners to get away with unstable reorgs. Another point is that proof of stake in Ethereum 2.0 will also make unstable reorgs much harder, although not impossible, and we still need to consider these sort of large, maybe $50 million reorgs that might happen where social consensus might not be enough. And as a final point, I'll say that this so-called stable reorgs could happen if we find a way to do them safely, and they should essentially have the same trade-offs as MEV extraction. And we should definitely investigate these further as a technical solution in addition to the social consensus solutions that we've been looking at. And finally, here's my email address if you want to reach out. And that ends my presentation.
Yeah, fantastic. This was really great. I think we have one question. If you want to answer that, we can transition to the next session.
In the chat or?
In the chat.
Okay. Oh, sorry. Did you mean like answer in the video or answer in the chat?
Either. You can just answer in the chat if it's easier.
Okay.
We can transition to the next talk now.
Okay.